Okay, we'll come back to this question in the alternating series. And it's asked me to find the value of p such that this series is convergent. If you remember, we have seen similar series to this one. We call it the p series. I'm sure you remember them, which is 1 over nb. And we know if p is greater than 1, this series convergent. If p is less than or equal to 1, this is divergent. But now I have the same similar question, but here for the alternating series. Now, what tool do we have to tackle such a question? The only tool we have is the alternating series test. Why? Because the alternating series test is the only test that will tell me if an alternating series is convergent. And if you remember, we have to pass two things in order to get convergence. The positive part should be decreasing and the limit should be equal to 0. So let's try to see when the positive part will be. Let's try to do them both, and based on that we check them. So first of all, solution. My positive part Bn is 1 over Np. Now the first equation, this must be decreasing. Now, if you remember, how do we find if it's decreasing or not? We go and find the derivative of a function similar to Bn. Now, if you find, I think this is negative b. And now, if you find the derivative, it will be negative b x to the negative b, negative 1, and this is negative b over xb plus 1. Now, it's clear that this is always negative. That's clear to everyone. There is a minus, everything else is positive. So Bn is always decreasing regardless of r. Oh, sorry, regardless of p. Now the second thing is we need to make sure that is the limit of Pn equal to 0? Maybe, maybe not. We just want to see when it will be equal to 0. Now, if it's equal to 0, the only way that this equal to 0 if this is positive. If it is negative, xp will go up and then the answer will not be 0. So only b greater than 0, and that's exactly what he is asking me to find. He said find the condition for b, and b must be 0. So the series is convergent if p greater than 0. Thank you very much for